Question 2, this question is about titration. 2.1, calculate the mass of sodium hydroxide used to make original solution, and then 2 of the parts. 9 times out of 10, when they give you a table with all these final readings, initial readings, titer, they want you to calculate a mean titer firstly. So that's what we're going to do. We're going to calculate the mean titer. And we know this mean titer will give us the volume. We've only got sodium hydroxide and sulfuric acid, so this will give us a volume of H2SO4. So it's going to be the ones that are less than 0.1 centimeters cubed away from each other. 19.60 plus 19.55 divided by 2. That gives me 19.575 centimeters cubed. Second thing we need to do is now let's find out the moles of H2SO4, because this gave us a volume of H2SO4. Yep. So now let's find the moles. We know moles is concentration on volume. Moles is going to be 19.575 times by 0.150, and that's in moles per dm cubed, so we need to convert this centimeters cubed to moles per dm cubed by dividing by 1000. That'll give me 2.94 times by 10 to the power minus 3. 2.94 times by 10 to the power minus 3. And now I can find out the moles of, well, this is of H2SO4. Now I can find out the moles of NaOH. Well, it's a 1 to 2 mole ratio, so it's just going to be my answer times by 2, which is 5.87 times by 10 to the power minus 3. Now here's a trick. We want the mass of sodium hydroxide used to make the original solution. And we know it shouldn't dissolve enough mass of sodium hydroxide in water to make this much of a solution. What we did was we found the moles of H2SO4 in a 25 centimeters cubed solution. Therefore, we found the moles of NaOH in a 25 centimeters cubed solution. So we want it in a 200 centimeters cubed solution. So we need to times by 8 our moles. Therefore, we need to times this by 8 to give me 0.04696. 0.0469, let's say that. And therefore what we're trying to find is the mass of sodium hydroxide. Well, we know moles is mass of MR. Mass is going to be the moles times by the MR of NaOH, which is going to be 23.1 plus 16 plus 1, and that'll give me 1.88 grams. Suggest why this might affect the titer volume recorded. When the student used a funnel to fill the burette with sulfuric acid, after filling, the student forgets to remove the funnel from the top of the burette. Well, if the student forgets to remove the funnel, what's going to happen is that the solution from funnel drips into the burette. Solution from funnel drips into burette, and therefore we're going to have additional drops of solution that could have entered the burette from the funnel. Therefore the value on burette is going to be lower. So solution from funnel drips into the burette, therefore volume in the burette should be lower. And then to state one advantage of using conical flask rather than beaker for titration, well, there's less chance of losing any solution, slash less chance of splashing any solution. And that is the end of question 2.